Good morning, good evening, good afternoon. Welcome back to the next episode of PM Powered's podcast. I am Wanda Curley, your authority on project, program, and portfolio management. This is brought to you by PM Powered, a consulting firm for project, program, and portfolio management. So without further ado, let's get on what I have for you this week. And I decided to focus on NASA. NASA does some wonderful things in the United States for the space program, but they've also had some catastrophic failures. And these are just the latest ones. This was categorized by Popular Science as the top 10, I wouldn't want to say catastrophes, but projects and programs that didn't work. So let's go to number 10. The Orbiting Carbon Observatory Satellite, or OCO as it was called. The mission for this was that NASA intended the OCO to provide an orbiting platform from which scientists would be able to look at how carbon dioxide moved through the atmosphere. Hyped as a space-down look at global warming, the OCO was supposed to help researchers figure out climate change. Well, what happened? I was absolutely taken aback when I heard about this. Sadly, the OCO never made it into orbit. As the case containing the satellite failed to separate from the rocket during launch, leading the whole assembly to crash into the ocean 17 minutes after liftoff. So what happened here? Well, it seems to me that testing was not done very well. Something occurred that that they weren't able to see that that there would have been the proper disengagement of the booster rocket, and it caused it to fall back into the ocean. Fortunately, it fell into the ocean and didn't hurt anybody. But so we're looking at the variables. If we go to the PM Powered project management triangle, you have the variables, you have the finance, and you have time. Time obviously wasn't an issue here, although it may have been on the program if they were trying to cut some corners to get there. Again, I don't have all the details, so I can't tell you exactly. I'm just kind of surmising here. But it seems to me that testing was done, or a corner was cut on one of the aspects of the launcher. So variables were not looked at, and this caused one of the sides of the triangle to start falling. And as the triangle starts to fall, then you can have catastrophic results with the program. And this is what happens when you allow one of the sides of the triangles to go down. So I'm sure they lost millions, if not billions of dollars on this. And it's a sad day for global warming scientists, because they probably would have been able to see things differently than from right here on Earth. So hopefully we'll have maybe the European space or even the Asian space people be able to bring up agencies to bring up a different satellite to help with this. So let's go to the next satellite. Demonstrations for Autonomous Rendezvous Technology, or DART, spacecraft. So this was a spacecraft. The mission was to upset with the expense and risk of launching the shuttle every time a satellite needed maintenance. NASA created the DART to show that a robotic satellite could dock with other satellites. DART was supposed to autonomously navigate towards and then rendezvous with an existing communication satellite. Well, obviously, since this is the top 10 and this is number 9, this did not work out. So what happened? And did it ever rendezvous? The computer controlling DART incorrectly estimated the distance between the two satellites, causing DART to bump right into the other satellite. DART then used up all of its fuel, essentially crashing into the ocean. So what happened here? Again, I think it was variables and testing. Did they not understand some of the dynamics of what the atmosphere is in orbit? I can't imagine that they don't. I mean, we successfully launched several spacecraft to the moon and back, although we did have Apollo 13, but we got it back. We understand after the disaster with the Hubble telescope, and we'll go through that in a minute, that atmosphere up in orbit, up in the stratosphere and stuff, is different than our atmosphere here. So what happened? Did you do testing, NASA? If you were the program or project manager on this, please contact me so we can discuss what exactly happened, what caused it to expend all its fuel and bump into another satellite. Something happened. I'm sure you did a root cause analysis. NASA, let me hear from you. This will be a wonderful case study for my audience to listen to. Okay, so that was number 9. Number 8, if you could see a picture of this, it looks like a arched flying wing. It's called NASA Helios. I would recommend that you go out there and look at the Helios because they've got several of them. But the mission, not actually a space probe, Helios was the last in a line of high-altitude, solar-powered atmospheric research platforms designed to fly in the upper atmosphere. The problem, while the previous aircrafts in the series succeeded in breaking a number of flight records, Helios just couldn't hack it. About 30 minutes after takeoff, Helios hit some powerful wind shear and crashed into the Pacific. Really? Come on, NASA. Did you not look at the weather? Did you not look at this? We understand how wind shear works now. You understand how all of this is working in the atmosphere. So what happened, NASA? Did you not see the wind shears coming? We can predict wind shears for aircraft, commercial aircraft flying, because we know how catastrophic it is to anything that's flying. So what happened, NASA? You look at wind shears for when you're doing space launches. What happened? Did you not look at weather? Did you decide this wasn't important enough for a weather launch? Or did a weatherman miscalculate? Again, I would love to hear the root cause on this. If you were the program or project manager, or you led the root cause analysis, I'd love to hear from you. I'm Wanda at pmpower.com. My listeners would love to understand what happened on this Helios. I remember following the various Helios and understanding what they did for us. If this had done successfully, this could have changed commercial flying. We could have maybe had some engines, or maybe not right now, but in the future, that are running off of solar. Okay, let's go to the Hubble Space Telescope. Remember, I told you about the Hubble? Okay, so the mission, the first in a series of space telescopes, the Hubble would allow astronomers to look at the stars without atmospheric interference. This would, and eventually did, provide the most detailed image of the distant universe ever produced. So the Hubble has been successful, but initially it was a catastrophic failure. Again, not with lives, but for its mission. So the problem, much like the nerds who designed these telescopes, Hubble had a vision problem. When grinding the original camera lens, engineers failed to compensate for the minute shape change the lens would undergo when moved into a zero gravity environment. Really? NASA, were you overlooking? What happened to quality control and quality assurance? Again, that's that variable's arm on the triangle. Time wasn't an issue, and finance wasn't an issue. They, as I recall in the Space Hubble, that they were within time frame, and they were within the money, the financial aspects of it. So we ended up having to, because of this catastrophic item on the lens, they weren't able to see out there. Everything was blurry. It was almost like you had to put on glasses to see what was going on. But of course, they couldn't compensate for it once the picture was taken. So what they ended up having to do was send up a mission up there, which of course cost more money because it wasn't sent, and it also affected the scientists that were expecting to be able to do all of this, and probably have put organizations together to do this, now had to wait another year or two before they could send up the corrective lenses. So again, NASA, what happened? Did you forget to tell the people that were designing the lenses that there were minute changes? Or was it within, once they got the information about the minute changes, and then were the lenses tested? Did they take testing to see if it could be seen the way it would be seen in space? So it sounds like there was a series of breakdowns along the way for the grinding of these lenses. So let's go to Genesis. This one I found very fascinating, and I think I vaguely remember hearing about it, but it was a very expensive satellite. So let me tell you why. Designated to catch pieces of the sun itself, Genesis flew into space to collect solar winds and specially designed sheets of gold. Yes, I said that right. Sheets of gold, diamond, and sapphires. Can you imagine that? Can you imagine if you could recover some of that, how much money you would make? By studying actual pieces of the sun, scientists hope to learn, excuse me, about the original composition of the solar system. The problem, it wasn't the grabbing a piece of the sun that proved to be a problem, but the bringing it back. The satellite was too delicate to simply land, so NASA planned to catch the capsule in midair by hooking its parachute with a helicopter. Except the parachute never deployed and the satellite slammed into the Utah desert. Luckily, those wafers were built tough and scientists managed to recover some of the samples of testing. First of all, my hats go out to the helicopter pilots because I don't know that I would have wanted to be on that helicopter having this piece of debris that's coming out of space hurling towards the earth, and you have to catch the parachute. Obviously, the parachute did not deploy. Now, we've had many things come back, and that's how Russia does it all the time, even with their manned space craft. They have them land back on land, and they have parachutes deploy. Was there any testing done, NASA? I got to believe that there was. Did you do a root cause analysis? What happened? Was it not packed correctly? All these things go through my mind, and all I can think of is the variables. Or maybe there was time and finance. Maybe there were some shortcuts taken, but the shortcuts go back to the variables again. If they were running out of time, maybe they took a shortcut on the parachute. But the thing is, it never deployed. NASA, I'd love to hear from you as to why it didn't deploy, and I'm glad that they were able to recover some of the wafers so that they could find out some of the things about our solar system. And I think they're still studying it because we hear about new things that are discovered all the time. So let's go to number 5, space-based infrared system, CBERS. So the mission of this, and it's actually kind of cool, and I just heard on television today that it's not cool to say the word cool. So anyway, I'm dating myself, I guess, but I'm getting off topic here. A series of classified surveillance systems called CBERS was supposed to answer the Air Force need for tracking ballistic missile launches. Consisting of high and low orbit satellites, CBERS is scheduled to go online next year. I don't know when this Popular Science article came out, so this is probably not correct anymore. So the problem, ignoring the $10 billion cost overrun. NASA, do you think you have a problem? A $10 billion with a B cost overrun for the project, and the possibility that it would not work at all. One of the first CBERS satellites shut down only 7 seconds after reaching Earth orbit. The satellite safety mechanism malfunctioned, putting the satellite into safe mode. Can you believe that? The satellite went into safe mode, and reducing it to when the Deputy Undersecretary of the Air Force called it a blank, useless ice cube. Blank. Blank being some adjectives I can't use on the air. But anyway, so there was a $10 billion overrun. So NASA, we got a problem. Second, it went into safe mode just 7 seconds after reaching orbit. What happened, NASA? Did you not run tests again? Did you put in a variable that you didn't expect that wasn't tested properly? How can it go into safe mode? Obviously, something jiggled or jangled or something was rattled to put it into safe mode. I don't know if this whole system has been abandoned, but it was I just can't believe it. $10 billion. And of course, this is taxpayer money. And again, this was for the Air Force. So Air Force, some of it goes towards you too, because you were the overall program manager on this. So what happened, Air Force? I'd love to hear from you. What was the root cause analysis of this? Okay, let's go to 4. I'm sure some of you heard about this one, the Mars Polar Lander. The Mars Polar Lander was part of an extensive 1998 push to study the red planet. The program consisted of soil probe, a lander, and a satellite. As the lander, the MPL was supposed to study the climate and surface of Mars. No one really knows what happened to the MPL. The spacecraft was successfully reached Mars, but NASA never made contact with the MPL. Anything from a faulty transmitter to a computer crash to interference from Marvin could have caused the failure. NASA still hopes to one day find the MPL and figure out what happened. Again, they can't do a root cause analysis because the thing failed on Mars. I will say that I don't fault NASA as much for this because this was one of the first items that went to Mars. So there was a lot of things that they could have learned, but unfortunately they didn't. They know it did reach Mars, but they're not sure exactly what happened. Maybe a Martian ran off with it, who knows? But once we are able to have more rovers on Mars, or maybe eventually if we land somebody on Mars, we might be able to find out what happened. Did it crash? If they find no debris, then that means it never made it down to Mars surface. Okay, so let's go to the next thing, Deep Space 2. So this is number 3. The mission sent to Mars, again, this was another Mars thing, on the same spacecraft as the Mars Polar Lander. The Deep Space 2 was a penetrator designed to burrow into the Martian soil and collect data on water and chemical composition. Much like the MPL, the fate of the Deep Space 2 remains a mystery. Both probes were built under the a faster, better, cheaper rubric that dominated NASA in the 1990s. Eventually judged as a failure, the ethos tasked NASA with generating a greater number of less expensive projects rather than the small number of large projects that dominated most of the agency's history. While NASA produced probes that were plenty cheap, many of them weren't as fast or better as hoped. So in the 1990s, and I do remember this, NASA decided they were going to do a lot of projects that were cheaper, faster, and better. Unfortunately, this didn't work out. They took many shortcuts that just didn't work for them. There were a couple of great successes, and the Mars rover was one of them, but most everything was a disaster because it either didn't land. You heard about the Hubble telescope. You heard about the Deep Space 2 and the other Martian probe that was supposed to happen. They had several others that did not work out. So after the 1990s, NASA decided to scrap the cheaper, better, cheaper, better, and faster mantra and go back to what it knew how to do. Do it like it's supposed to be done. Okay, so let's go to number 2, the Mars Climate Orbiter, the MCO. The brains of the 1998 Mars mission, NASA intended the MCO to serve the dual function of studying the Martian atmosphere and relaying radio signals from the 2 surface probes. And one of the all-time great engineering gaffes, NASA subcontractor Lockheed Martin created thruster software that used imperial units. Lockheed, what were you thinking? Not the metric units used by NASA. NASA did not know this. How could NASA not know that? How could this not have been caught in the early designs? So NASA never converted from the pounds to newtons, and the probe eventually hit the atmosphere at the wrong angle and burned up. This is the second thing that we've heard of Mars on a Mars probe where they used the wrong metrics. One was metrics and one was imperial, or one was metrics and one was US. So NASA, hopefully you've learned your lesson on this, to check one of the basic tenets that you're all using the same metrics, the same conversion, or you're using the same units to measure. I'm still dumbfounded. This was something that we learned very early on as a project manager to put out the specs on how you're going to do things on your project. So are we going to use US metrics, or are we going to use, US measurements, or are we going to use metrics? Are we going to use what they use in Europe, in England, or are we going to use what they use in Europe? So there you go. So the last one is the NOAA, NOAA 19. And this one, it's so bad, it's laughable, but it's sad, because it goes to show that even NASA forgets some of its protocols. So the NOAA 19, which was a satellite, was the last in a series of weather satellites that monitor atmospheric conditions, follow volcanic eruptions, and conduct climate research. The problem: there have been satellites lost in space, those that have exploded on the runway, and then there's this. During final servicing at a Lockheed Martin facility in California, engineers failed to check if the satellite was bolted down before moving it, and accidentally knocked the multi-million-dollar piece of equipment onto the ground, breaking a number of components. Whoops. Lockheed, what happened? You guys are known for safety. You guys are known for following protocols. What happened? I hope there was a root cause analysis to find out who lost the ball on this one, and I hope there was some more training put in place. I don't hope that anybody lost their job unless it was maliciously done, but I do hope that this was, because can you imagine if this had been done for something that was commercially related and somebody just decided to skip a safety factor, and then that plane was put into production? Oh my gosh, my heart breaks on something like that. And there have been things like that. When I was in the military, we've actually had planes that lost wings because when the plane was going through servicing, the wrong caulking compound was put on between the fuselage and the wing of the plane. So things like that happen, but they should not happen, because if you're following what you're supposed to be following, your checklist, then things like that don't happen. However, we get complacent. We think we know it, and we just go on rote memory, and rote memory doesn't always work. I hope you've enjoyed these 10 items from NASA. Some of them were comical, some of them were downright sad. But they show to you that within project management, we have to look at all aspects, and the whole team has to be working on it. And you as the leader have to understand the neuroscience that's driving all of these. If you see your team becoming complacent, jerk them around, get them to do different things so they start seeing from a different perspective. You need to understand why your team performs the way it does. So if they are detail-oriented, maybe they're missing the forest for the trees, so you have to put them into that type of job. Now, I understand in NASA you can't just pull a rocket engineer and make them a terrestrial engineer, but you can put them in doing a slightly different job within their rocket area or their terrestrial area. So constantly be looking on the lookout for the mental health of your organization, because they may need some shakeup to get them out of that complacency that you find them in. If this has interested you, please go out to pmcurrent.com and make sure that you follow me on Twitter, LinkedIn, YouTube, and Facebook. I'd love to have you following me and giving me insight. If you agree with what I've said, or you were a project manager or program manager, or did the root cause analysis on any of these episodes that happened in NASA, I'd love to hear from you. You can reach me at wanda@pmpowered.com. Again, this was brought to you by PM Powered, a consulting firm in project, program, and portfolio management. I'm Wanda Curley, your authority on project, program, and portfolio management. Thank you for listening, and I look forward to talking to you next week. Take care and have a blessed week.